In this video, we're going to look at the probability of events involving not. This is a very mathy way of saying that we're not going to be looking at the probability that it is to roll a 2 on a die. We'll be looking at the probability of not rolling the 2. So the probability of an event not happening. To consider this, we need to look at a concept in math called the complement. Now here we're not talking about saying nice things about people. The complement of something is in math is basically what is needed to complete something. So when we're talking about the complement of an event, we're talking about the other side of the story, so to speak. So if we're talking about rolling a 2 on a standard 6-sided dice, then the complement of that would be not rolling a 2, because if we put those two together, then that considers all of the options. That takes into account all of the options. So another example might be picking a red card from a standard 32 deck of cards versus picking a black card. Those two situations taken together is all of the possibilities without any overlap between the two. So that's the two key factors. It takes into all of the possibilities in the entire situation, and there's no overlap between the two. So it wouldn't be a complement to say picking a red card versus picking a king, because those have overlap between them and they don't include everything. Or it also would not be the complement to say picking any card from a deck versus picking a king, because they have overlap between them, even though that would get all of the options out there. So it has to have all the options that are possible, and there can't be any overlap between them. So they complement each other or complete each other. All right, so something you might notice with picking a red card and picking a black card is that's essentially half and half, so 50% and 50%. But this makes it real easy to see a nice feature of complements. If it takes all the consideration into account, when you add them together, you'll get 100% of the possibility. Okay, so whatever the probability of rolling a 2 is, and whatever the probability of not rolling a 2 is, if we add them together, we'll get 100% of the probability. We usually express probability in terms of a fraction, so this would be 1/2, this would be 1/2. So when we add them together, we get 1, which is the same as 100%. We're going to be doing it with the fractions and then adding them together, you get 1. Now something we have talked about is the probability of an event. We'll say the probability of event E, to be able to use some nice symbols, has to be less than or equal to 1. It can't be any bigger than 1. And it also is greater than 0, but we're going to focus on the 1 part right now. So if the probability has to be between 0 and 1 and adds up to 1, then when we write this idea of complements out using our fancy symbol system, we get that the probability of some event E occurring plus the probability of that event E not occurring would equal a 1, or add up to 1. And this is the same thing we saw when I was using the actual examples of drawing cards or rolling a 2. So if I turn the same idea around on its head, I get the idea that 1 minus the probability of event E occurring will equal the probability of the event not occurring. If I add them together to get 1, then if I start with 1 and subtract one of them, then I will get the other one necessarily. So this is the idea that we're going to use to determine the probability of some event not occurring. And the whole idea behind this is sometimes it's really straightforward to figure out the probability of an event occurring. Sometimes it's really straightforward to figure out the probability of an event not occurring, but we can use this principle of complements to figure out the opposite. So we can find whichever one's easier and then use complements by subtracting subtracting what we know from 1 to determine the probability of something that's more challenging to find. Let's look at some examples so you can see how all this plays out. Alright, so we are going to draw one card from a standard deck of 52 cards, and we want to look at what the probability of not drawing a heart is. Now in this case, the probability, finding directly the probability of not drawing a heart is more complicated than finding the probability of drawing a heart. We've actually already done stuff like finding the probability of drawing a heart. However, in this case, it isn't too bad to find the probability of not drawing a heart directly, but we're going to use this as an example to build this idea of how to use complements. Okay, so we have the general idea that the probability of not drawing a heart would equal to 1 minus the probability of drawing a heart. And that's using that complement rule, that if they add to 1, then if I take 1 and subtract one of them from it, I'll get the other. So here we have our 1, and then the probability of drawing a heart we've looked at before. There are 13 hearts, and there are 52 possible cards. Alright, and then when we do the math with that, you could just punch this into your calculator, or you could think of the 1 as 52 over 52, and then minus your 13 over 52. That gives us 39 over 52. If we reduce that, we get 3/4. And, you know, it's easy enough to sort out in our heads that 3/4 of the deck is not hearts. If 1/4 of the deck is hearts, then 3/4 of the deck is not hearts. So, like I was saying, this particular example, it's not so bad to figure out the not side of things. But I'm using kind of a transparent example here so you can see how it works to use the complement to find the probability of something not occurring. Sometimes it is easier to find one than the other, in which case we would find the one that's easier and then use it to find its complement. Sometimes we just flat out don't know the complement, and so we use this property of complements in order to determine it. Let's look at an example like that. Again, I hope this next example will be pretty logical to you so you get the idea of complements, but it's the kind of case where you know one thing and use it to determine the other. If the chance of rain is 36%, what is the chance that it does not rain? Now we had been using the 1, and most of the problems we'll do will be subtracting 1, but since this one's already expressed as a percent, we're going to take this as 100% minus our 36%. So we're essentially subtracting the 36% from 1, but doing so as a percent. Doing that gives us 64%. So if the chance of rain is 36%, then the chance of it not raining is 64% to give us all a possibility of 100%. So hopefully this gives you an idea of how to find the probability of an event not occurring. So when you're reading problems, if you see that word not, that's a key indicator that what they're trying to get you to do is to find the event of it occurring and subtracting it from 1. So go ahead and give a few of these a try and see how you fare.